am Revathi, Assistant Professor, Department of EEE, SNS College of Engineering. In this lecture series video of electron devices and circuits, today's topic is PN junction diode. So, why the PN junction diode is named as PN junction? PN junction diode is a non-linear circuit element and many signal processing functions needed that is signal rectification. A PN junction device is a type of semiconducting device. It's widely used for the applications like rectifying, clipper, clamper, etc. Photodetector, light emitting diodes, and laser diodes. Overall, the diode based components are always built up by using a PN junction diode. The simplest simple representation of PN junction diode is an anode terminal and a cathode terminal, whether the anode terminal is named as P type and cathode terminal is a N type. So the combination of both B and N type cathode and anode is known as PN junction diode. When a p-type semiconductor is brought in contact with the n-type semiconductor, the contact surface is called p-n junction. A diffusion of electrons and holes on the majority carrier side to the minority carrier side until drift balance diffusion. And a valence voltage is created and a potential barrier is also created across that junction. A p-n junction diode, whether in p-type there is the holes present as a in a p-type there is an hole present as an majority carrier, and n-type electron is an majority carrier. In between those two junctions there is a mild layer called a depletion layer or else a depletion region, a region near to the p and n junction deployed from free carrier because of the majority carrier diffusion, leaving only fixed positive and negative junction is known as a p-n junction depletion layer, where the small flow up of the E barrier potential is a large concentration of an valence bond to a conduction band. A small concentration of holes is transferred, wherein the valence band to conduction band, a large concentration of holes is created in the P type. Forward biasing of PN junction. So, speaking as PN junction diode, forward bias and reverse bias, that is the two types of biasing are present in PN junction diode, where in reverse bias there is no current flow, in a forward bias there is an conduction. So in forward biasing of PN junction diode, a region is made positive with respect to n type, whereas in reverse bias condition, P type region is made negative with respect to n type region. PN diode current components under different biasing is, where see the direction of the magnitude of a drift current carefully. Drift current almost remains constant as it depends mainly on number of minority carriers. So the flow is defined as where there is a majority carrier, a small amount of minority carrier is present in each type, whereas in P type, holes act as a majority carrier and electrons act as a minority carrier. Here in N type, holes act as a minority carrier and electron as a majority carrier, where the majority carrier tries to attract the minority carrier from the other junction, where the junction is created. VI characteristics, where voltage current characteristics of PN junction diode is, where in forward bias condition there is a conduction, where for a diode, speaking as a diode, there is a semiconductor involved in it. The two types of semiconductor where we used in this PN junction diodes are germanium and silicon, where the germanium's breakdown point is 0.3 and silicon's is 0.7, where the conduction in the reverse bias is termed as an leakage current. Rapid increase in the IED diode current when reverse bias voltage exceeds a breakdown voltage. Breakdown mechanism is either avalanche or Zener breakdown, where avalanche breakdown in both P type and N side of the diode are lightly doped. Depletion region at the junction with an application of a very large electric field at the junction may rupture covalent bonding between electrons, where in avalanche breakdown generation large number of charge carriers resulting in avalanche multiplication. Zener breakdown, both P side and N type sides are heavily doped, whereas in avalanche breakdown it is lightly doped, and while in Zener diode it is heavily doped. Temperature effect on the PN junction diode. V on varies linearly with temperature, which is evidenced by the evenly spaced curve for increasing temperature in 25 degrees Celsius increments. Temperature effect. In the forward bias region, the characteristics of silicon diode shift to the left at the rate of 2.5 meter voltage per Celsius increase in temperature. Where the diode approximation is when the diode is forward bias, resistance offered is 0. When it is reverse bias, resistance offered is infinity. It acts as a perfect switch. When forward voltage is more than 0.7 volt for SI diode, then it conducts and offers 0 resistance. The drop across the diode is 0.7 volt. When reverse bias, it is often infinite resistance. Load line characteristics. The straight line represent the above equation is known as load line, whereas in the curve we can see across our diode current and diode voltage, where the straight line is for a load line. So important terms of PN junction diodes are breakdown voltage, knee voltage, maximum forward current, peak inverse voltage, maximum power rating. Thank you.